And this is some of the thermal gravity analysis and the derivative thermal analysis of untreated and treated fibers. So when we look that one, not much changes is coming on, in the untreated and treated fibers in case of that. Very minor changes is coming. And similar with the tensile and modulus of the composite, when we make the hybrid composites, we find out that one, the P30 means that the pineapple leaf 30%, that one, they are giving the better properties tensile in compared to the hybrid composite which we make, because as we look into the earlier that one, the pineapple have better cellulose content compared to the coil. Because of that, the pure composite, when we make with that one, the pineapple, it gives the better strength. And when we are hybridizing, so hybridizing, that means that here we hybridize and improve the coir application. So because of that, we hybridize with the pineapple. So when we are looking into the hybridized, so we find out the 50-50 is giving the better mechanical properties in case of the hybrid composite. Further. And we have also done the flexural. Flexural also the similar trend we find out here. Here also we find out, but the impact strength we find out that in the pineapple leaf is lower, because as you know that the coir fibers, oil palm fibers, and these fibers have a toughness is high. Because of that, the impact properties of the coir-based composite is better compared to the pineapple. Further. Then we done the density. We saw that the neat PLA is there, and then we little bit improved the density in case of the hybrid composite. And we have also measured the water absorption and thickness swelling of the composite. Please.
Chicken biryani.
Enough, one chicken biryani. Then we have done the one study we call the dynamic mechanical analysis. In there, you can look the stiffness and properties of that one, how that materials are behaving with the temperatures compared to the mechanical. We only study the mechanical. So we done the storage modulus, loss modulus, and tan delta, and we analyze it that one beside the thermal property, TGA, TMA, and TMA is one of the property you want to analyze the physical properties of the materials with the temperatures. Further. And we have treated the hybrid composite similar with that one, and we find out that one, the treated hybrid composite have better mechanical strength compared to untreated. Further. And we have also looked into the flexural. So flexural also find out that the treated have better properties compared to the untreatment. Because of that, they have a better interfacial bondings between that one. Further. And the impact properties wise, when we look into the impact properties, we find out that one, the 50-50 is still okay here also in case of that one. And water absorption, we find out that the coir 30% and 70% pineapple have a higher water absorption compared to the other composites. And in case of the thickness swelling, we find out that the coir 70% and pineapple 30% have a higher thickness swelling. Please further. And this is similar we done with the untreated, and we compare with the treated with that the thermal properties in form of the DMA and in form of a TMA and in form of the TGA. We done that one and find out that one, the treated is doing a better extent that properties also. Further. And we also done the accelerated weathering test on that one, and we measure the different properties of the untreated and treated on the soil boreal test also. And we find out like 250 and all these things. Go further, it's okay. And this one we also took the images of unweathers and accelerated weathering, untreated and treated carbon, pineapple and PLA composite. Further. Because we have limited time, so I'm not going for the, and these are the different parameter we use it that one. Go further. Further. Yeah. So we find out that one, just go with that one. So we find out that one, these investigations have the treated by investigations, and we find out that the hybridization of coir fiber and their incorporation in the PLA matrix have incorporated the mechanical, thermal stability, physical, dynamic, and thermal properties of the hybrid composite compared with the untreated composites. and there is some improvement in the physical property. And this is, we make a prototype, we make a one mold, and we make a prototype of that what called as the tray, food tray. And we also done this tray also. We put into the degradation and find out that one within 3 months or 4 months that the tray is degrading into the soil. Further, just go further. And these are the different publications. So if anybody want to, because I just take very superficially on the research, because there are a lot of details are there. So these are the different journal publication from that work, which I stated here. So if you want to go into the further study, into the details, you can read this 6 paper published from this work. Further. And there are some conference paper also published from this one. Further. Now further I talk about the one international project which we done on developing a safe biodegradable packaging by the Malaysia and the UK. And that project we need to develop at that type of product which is a biodegradable product, 100% biodegradable. And that project need to impact to the Malaysian economy. So because as you know that the Malaysia is a oil palm producing country, and they have an abundant amount of the oil palm empty fruit bunch fibers. So we push into that one, how that packaging material can be developed from the oil palm empty fruit bunch fibers. Further. So this is, you look into that one, is it metric tons of 1,000 of metric tons of the oil palm empty fruit bunch is outside of the oil palm mill. And if it cannot be utilized, it can become a disposable problem for these materials in the futures. Further. So if you look into the flow charts, we take into the oil palm empty fruit bunch and we extracted the fiber from that, and we have to do the pulping from these fibers, and pulping can be make a pulp molded product. Please go further. So why we choose that one? This is a cheap material and it can be waste to wealth and low lignin content, high fiber content, and good bonding strength and paper making properties of the oil palm. Further. So this is, just go further. Please, next slide. And we also studied that the toxic properties and other properties of that one. Please go back. Please go back. Please back. Yeah. So there are different properties of the pulp molding. You can use the wet type or you can use the dry types of that one. That is the mechanical process. And this is the pulp molding where the wet type. So we use the wet type of things in the Malaysia, and we use the dry types in case of the UK. Please go further. So this is a setup of one company in Malaysia where we done this pulp molding product. Further. So this is, we make the pulp in our institute laboratory. We make there the pulp 30 kg because they need at least 30 kg of pulp for running a one production line, Go further. So there is a pulverizer. You can put into that the pulp into the pulverizers, and then here you can mix up. If you want to make a water resistant, oil resistance, and anything, you can further modify that in the pulverizing tags if you have anything modification you want to do into the pulp. Further. Then you saw that it's putting here, and then the high speed agitation, low speed agitations are there, and they can mix properly with the waters. Further. Go further. This is the pulp slurry was pumped into the holding and mixing tanks. It will mix very properly before going into the pulp mold. Next. So this is the pulp molding. You can do the mold as per your design. What type of materials you want to make? You want to make a plate, you want to make a lunch box, you want to make any other things from that one, cup, and all these things are there. So this is the panel settings and all these things are there in the company. Further. So this is the food container with dried and cured. Basically is a video. So unfortunately, because I'm not sharing here, otherwise I show the video. Go further. So this is the product we developed from that first of our trial. In that one lunch box we done, because they say that if you are able to make a lunch box, then very easy for you to make a plates and other things. So we look into that one. That everything is very nice, positive finding from that. We put the waters and char. Bonding with the waters and oil repellent agent can be put into the later on if you want to make it a water or oil repellent. Further. And this is second trial. We done also the second trial on that. Further go. Next. So in this trial, we make the plates, because that type of setup, the factory is running the plate production. So we also make the plate that from that time. Further. Yeah, this is because it's a combined project going on. So one side, the UK is also making that by using a oil pump. We send the oil pump. So they try to make a punnet, but they have some issues. Further go. So they have not getting the good types of the pulp molding from the mechanical process they are using there, mechanical pulping. Further. So we went to UK and we look into that was the problem with the industry guy, and we find out that they have a mold problem. So we try to solve their mold problem. We make the mold in Malaysia. Further go. And then we send the mold to the UK. Further. So we make the new mold for them, mold design for them. And then we send this mold to UK and we install there. And after that, that's working perfectly, for them. Go further. And this is also the video, but I don't think it's possible to, because I have here the things are there. Okay, go further. So we also that like Mahadev have already explained you the life cycle assessment and all these things with the biocomposite. So basically that we also try to analyze the life cycle assessment of this pulp molding process. So we went to the industry and we are work with the UK team, which come to the Malaysia, who have one guy, Paul, is expert of the LCA assessment. So we done that data process from that. So we look the all aspect of that one. Further. Go next slide. So we also analyzes, the materials as he further explained, the transportation process, pre-treatment, pulp moldings, and all these things. And we are still, these are some of the data we measure through the equipment we install there. Further. And we try to what the mold we make, what the tray we make from that our product. We try to compare. So Tesco UK is also the one of the partner of this project. So we take the plastic, we put the current plastic punnet with mushroom, we put our tray and we put into that one the mushroom packaging, and we try to look that one how this going to performance on the basis of shelf life and the people demand. Further. So this is another, we developed the one leaded pulp molding tray. The beauty of this tray is that one, the tray is 100% degradable, and the film is using that one is also the cellulosic film, and the adhesive used in there is also a bioadhesive. So it's 100% that one. You can use it for the high expensive materials or what call that the packaged foods or something, you can use this one. So this is a tray sealing. This is the cellulosic film we use for this tray. Further. And we also try to put that, the different types of materials in our tray, the fruits, tomato, and all these things, and top seal. And we want to look the main things of the shelf life. Is it, because one of our challenge is that one, that for them, the hypermarket in Tesco and all these things like tomato, mushrooms, and all these things, they put it is spoiled very fast. So they say, like, for example, if the mushroom is 3 days, if you extend through your packaging the 4 days, we have a millions of saving from that one. So we try to do that one, and we find out that original packings and in the packing of our tray, the what call that the weight changes is higher compared to the existing one. Further. And then we also check with the chicken meats, we transfer the pulp molded tray, top seal wrap, kept into the suggested condition, weight changes monitor for that one with the coated tray and coated tray with the chicken. Further. We also done, and we face the problem that when we put the chicken, it's what called the water is coming and touch what call that the is not properly. So we use the type of papers which can be absorb the waters coming from the chicken, and monitor the conditions and all these things. No package failures were identified over the testing periods in this case. Further. And this is the things we put into the Tesco headquarters. The plastic you saw the left side is the existing product of the Tesco, and this is our safe bioproduct, and we put it that one, and we ask the consumers to give their opinions on that. Go further. So we find out that the 80% of the consumer found that the safe biopack packaging acceptable as produced packaging, 8% found it neither acceptable or unacceptable, and 7% found it unacceptable. And the plastic packaging, at 42% of the consumer found that plastic packaging acceptable as produced, 27% found it neither acceptable and that. So the acceptability to the peoples are very good of this product. Further, we also look into that the distributions of the responses, 9%, that the who responded, and that one. And another product we also done with that one by using extruder and the thermoforming machines, using the oil palm with the biopolymers. Further, just 5 minutes I will take that one. I'm looking that I take more than 30 minutes, so sorry for that, just 5 minutes more. So we develop a composite sheets by using a what call that the composite through the what you call as the mixing the oil palm with the biopolymers, and we make the sheet. Further, and this is, you saw that the composite sheet and cut into the sizes. And further, just for your information, all these things, the making a composite sheets and all these things, we've done a lot of trials and all these things, and after that we come onto the what call that the formulation. That formulation we use for that purpose. So you look that one, we do the thermoforming what call the product by using that sheet, composite sheet break from the vacuum forming multi-vac machines. And further go, we also make by the what you call that's the thermoforming or thermoforming further. And this is also in the using the hot press in lab, just a hot press. We also developed that one, the composite packaging tray, and we have done from the oil palm and others materials. And go further, these are the others. We use the canaf material, similar like you can use the bamboo, wood fibers and all these things. And possible to white one is the pure biopolymer tray, and this is mixing with the canaf and biopolymers tray, this one. Further, and if you look into that one, the biodegradable, because we are talking about a lot of people have confused with the compostable and the biodegradable. So if you want to send your product to the Europe, you must have a EN 13432 standard, which is commonly called the bio-based content, which is the percent. What is the content of that one? What you need into that one? Second slide further. So this one, your compostable means that one, the packaging materials and relevant organic composites are naturally biodegradable. You are not going to use any chemical process or something to degrade it. Disintegrations of the packaging material take place in composting process for organic waste. The packaging material has no negative effect on the composting process, and the packaging material does not negatively influence the quality of the compost. So this must be, if you follow, then you can do into that one. There is another standard called ASTM D6866. This is also applied to the US, and this have a different content. That one, if 25% of the bio-based content is established, or you have now more than that, so they have the different types of that one. There is another in the Europe, they use Vincote. There is also, they have different, that if you have a between 20, they have the different logo according to that. So between 20% to 40%, between 40%, and that is another. Go further. No problem. Dincote, there is another they use in Germany. They have also on the basis of the how much the bio-based content and in that materials. According to that, you can use that type of logo. Further, this is another CRIP eco-labeling in Malaysia. Similar like we have, if you look into the India have an Indian EcoMark, So you have to follow that standard in case of the India. Further. And if we look into the market, biodegradable market of global trend and forecast. So if we look into the plastic market, is expected to grow as per the CAGR. There is one organization which gives the predictions of that 18.05% from 2013 to 2019, and this is going to reach to the value of the 8,000 millions, and the fastest growth in biodegradable packaging is going on, and they are predicting that it's going to grow up into the multi-billion business. Go further. So this is the future of that. Just go before that. Further back. Back one more. Just one back. Last slide, this one. So if you look into the future of biodegradable packaging market, food and beverage is taking the 60%, pharmaceutical is 25%, and other are taking the 15%. As raw material quality and availability increases and technology advancement, the quality of biodegradable product will become available to the market in volume at a competitive price. At this point, a large real market will emerge. The main problem that we make the product from biodegradable, but when we are going to sell it, that one, their price is higher than the plastic. And it's challenging for any businessman or any consumers to take that product. If that is available in 1 rupee, then you want to give the biodegradable in 2 rupees. Very few people are going to buy that one. So if the demand will increase in the futures, the biodegradable product will compete more with the price wise from the non-biodegradable products in the futures. And slowly the price of the biopolymers is also reducing with the times, with the demand, so that can be done. And lastly, I'm thankful to the Newton Wango Umar Fund, supported by the Newton Fund, My Innovative UK, Research Councils UK, for supporting this work through Newton grant number 6300873, UK and Malaysian industrial and academic project partners. And I'm also thankful to the organizer of the today webinar from the Institute of Wood Science and Technology, Bangalore, India, who invited me to share my ideas.